Fab. Okay. Hi everyone. Thank you for coming to the Year 2 maths meeting. I'm really sorry if it's a bit noisy. There's gymnastics going on outside, so just bear with. But yeah, so welcome to Year 2's maths meeting. I'm really hoping tonight gives you a deeper insight and understanding of how we teach maths at St Mary's. But more importantly, I hope that it supports you guys in helping your child to reach the age-related expectations by the end of the year. So obviously I want to let you know what we get up to, but also ultimately what you guys can do to support your child in Year 2. So thanks for coming today and giving me the opportunity to go through this with you, and I hope it helps. So just to go over the aims for today. The aim of the workshop this evening are for me to outline the national curriculum, so what your child will need to know in order for them to really to reach the expected standard at Year 2. So we'll talk about what they need to do and what we do at school to support them to reach that. We'll also talk about the approach that we take at St Mary's, which is a mastery approach, which has been recommended by lots and lots of people. We've had lots of training in it, and it's adopted by lots of schools. We also follow the White Rose Math Scheme. I'm sure lots of you have seen some of the stuff we did during lockdown and things like that, but we use that to support the children. So it has lots of resources, lots of the worksheets are broken up into some of the stages I'll talk to you about through this meeting. But I hope that you guys can take some ideas away on what your child needs and how best you can support them. So the primary maths curriculum. So throughout our maths curriculum, we're working towards the children to be able to become fluent mathematicians, for them to be able to reason mathematically as well as solve problems, which will hopefully help them in everyday situations as they grow older. I think it's really important that we explain to the children and that they're aware that maths can help them with everyday jobs and everyday things, that maths isn't just about we just do it in school because we have to do maths. I think it's really important that we make the children aware why we're doing maths. So we're doing this so, you know, we can tell the time, or so we can do all these things so we're not late for school. That's why we need to tell the time. So I think it's something that you can support them with in everyday life, like paying with money. That's something we're on at the minute, and I think a lot of children are finding it harder than I imagine, because I think we don't really use money anymore. I think everything's so contactless now that we're not really sure what a penny looks like or a pound looks like. So I think it's still important that they are getting to hold money and play little games with it and seeing how much things cost. So I think it's really important that children have a purpose behind their maths, why we're doing it. And I think putting it into everyday life can make it easier for them, and they can see sort of why we're doing it. So I do think that's really important, that we keep reiterating why we do maths and pointing out to the children, oh, you can do this because you've learnt your maths. So that's a really important thing. So we also help the children to reason. So we have lots of talking, getting the children to say why they think that, instead of just always coming to the answer. Now, there's some children that can just get the answer, but they don't actually know how they've got there. So we're really encouraging that mathematical talk, developing an argument. Some people think this, some people don't think that. If they can back their answer up using the mathematical language, then that's really super. I think also ensuring that we're building up that perseverance through maths as well, teaching the children the correct steps to answer things, but also can they persevere? If they didn't get it right the first time, that's okay, let's try again. What can we change? Which numbers did we get wrong? What step didn't we follow? And trying to really discourage that scribbling out, I did it wrong. It's not wrong, it's your thought process, but let's have another go. And I think we're working really hard in school with that. And I think the girls quite, you know, they get caught when they do something wrong, they really want to like scribble it out, and we're just trying to say to them, it's not wrong, let's have another go, and sort of discourage that oh, I've done it wrong, and that sort of panic about maths, because it doesn't need to be there. So it's really supporting them with that aspect. So we want them to be fluent, we want them to be able to reason, and then that leads into the problem solving to help them again in everyday life aspects. So moving on to the curriculum that we teach at St Mary's. So we teach a mastery curriculum. we've had lots of training on this, like I said, and it's proven to be a really effective approach to maths. It means that the whole class moves through the content at the same time, encouraging the children to think deeply about the content. So we're not just moving through really quickly, we're making sure we're developing that deeper understanding. I mean, in the past, I think, schools just whiz through it, and actually the child might get the answer right, but they don't understand how they've reached that answer. And we really want to avoid that. We want them to know about tens, about the ones. So we really help this mastery approach is really helping to support that. And we hope through doing this mastery approach, we hope this helps to build self-confidence learners who are independent. So all the skills we're teaching them, we're hoping that they can develop that independence, that when they see a question, it's not, oh my goodness, I don't know how to answer this. They have the skills and that deeper knowledge to take the correct steps to come to the conclusion and come to the correct answer. Now, in terms of how we differentiate, we do this through acceleration through depth rather than acceleration. So we wouldn't just put someone onto a year 4 curriculum. Instead, we would challenge them within the year 2 curriculum. Although they're a high flyer, there's different ways they can solve problems, and really challenge them through that depth rather than putting them onto a different curriculum. So that's an overview of the mastery curriculum. So here is just an overview of what we cover in year 2, and it shows how it's broken up into the 3 terms: autumn, spring and summer. Something just to be aware of is, obviously, with the children sitting SATs in year 2, which will be in May, we do need to have covered everything by then, so that we are having to move at a quicker pace, but still enabling that deeper understanding. But we do need to do it a little bit faster to cover it. However, we're not teaching it in depth, we're covering it in different ways. So for example, time, I'm not going to leave time till summer term. We started it in year 1, and we're building it into everyday life. For example, when we go to lunch, children, what time is it? Getting them to look at the clock. Oh, it's 12 o'clock. We can see where the 2 hands are. So bringing that into everyday life, and I'd really, really suggest that you guys are doing that at home as well. What time is it, Mum? Oh, let's have a look. Getting them to get the clock out, getting them to look where the hands are. And it can take, it takes a minute just to have a quick look at a clock rather than just telling the children. It is a year 2 objective. So as much as you guys can do at home with just drip feeding it in throughout the year, thinking about what time the children go to bed, what time they brush their teeth, what time you have your tea, and just having those little conversations about what time it is will really support them. If that question was to come up in their SATs paper, they've had so much practice, and it not just being done for a week in summer term. So that's how we're really dripping things in, to make sure we're covering all the content, because there is lots to get through. And it's the same with position and direction. We can do that in all aspects. A lot of it can be done in PE, getting them to change direction, thinking about which direction they're traveling in, thinking about their position. So it's all about, I think, sort of being clever with our curriculum and making sure that we're not missing anything, but also utilizing the time that we've got before May. And then obviously after the SATs, we'll have more time to recap, go over things that were not as strong. But we do have to make sure we've covered all of the curriculum before. So just a little bit of an in-depth knowledge for you guys. So this is sort of when we go onto White Rose and say, we always start, like I showed here, in autumn term, we always start with place value. And this just shows sort of the steps that we're taking in our mastery curriculum. So in autumn term, like I said, we always start with number and place value. And one thing we're spending a lot of time doing in year 2 is making sure we can count in 2s, 5s and 10s and 3s as well. And we're really supporting the children, and they are getting really good at this, but the more practice, the better. And I'll come on to our times tables a little bit later, because I know lots of them have been excited about starting on their times table rock stars. I'm sure you've heard about that we've done this week. So often counting in 2s, 5s, 10s and 3s, it's often a case of practice makes perfect. Doing it, the more that they practice it, the easier it becomes, and just sort of going through it. So just going back to when the children were in reception, they really deeply focused on numbers up to 10. In year 1, we deeply focused up to the numbers of 20. And now that we're in year 2, we've moved on to really focusing on numbers up to 100 and building on the work that they've already done. But like I say, they've got to understand each step of that. They had to understand up to 10. They have to understand up to 20 to now understand the numbers up to 50. So a lot of the work that we're doing is really deepening that understanding of numbers. And we're also progressed on to things like comparing numbers, so using symbols to show greater than, less than, and equal to. But again, that springs from place value, understanding, for example, 52, the 5 is a 50, not a 5. So it's having that understanding of the place value is really, really vital. And I think if a child doesn't understand that, they're going to struggle. So we have to really, really break that down. And as you can see, the steps and white rows that we follow are really broken down, and they give us lots and lots of time to sort of focus on that. So as they were in year 1, they were learning their number facts to 10. Now we've progressed on to number facts to 20. But this is a vital part of year 1 and year 2, is knowing those facts, like I said earlier, fluently, off by heart. They don't have to think about it. They know that 4 and 6 is 10, things like that. So that's really knowing their number facts to 20. So just moving on to spring term. As you can see, we move on to money, which we're covering at the minute. And like I say, getting that money out, showing them it, making sure they've felt it, they know what they look like, is a really useful thing you guys could do at home. And then we'll move on to multiplication and division, which can be quite a tricky aspect, but we'll do lots of, have lots of resources out for the children to physically manipulate things to support them with this. And then we move on to measurements and maths. So that's an overview of what spring term is sort of covering. Now, the next 2 slides give you an overview of the 3 different levels that children are assessed on. And by the end of the year, they will be at one of these standards. So at Parents Even, we spoke a lot about the different standards the children will be at by the end of the year and where they're predicted to be. So there's working towards, the expected, and greater depth. So working towards, they haven't quite met the year 2 standard. Expected is they're exactly where they should be. They're hitting all of these bullet points that you can see on the screen. And greater depth, which is on my next slide, the children are working slightly above year 2 when they're hitting the points. So I'm not going to read these all to you. I'll make sure this is uploaded onto YouTube for you guys to have another look at. But it just kind of breaks steps down into what the children need to be able to do by the end of the year. And they're built on, so they get a little bit harder sort of as we go down. But yeah, that's sort of a highlight of what I'm sort of assessing them on, and that sort of builds as we go through the year. So obviously they wouldn't be able to do some of these yet because we haven't covered it yet, but by SATs they will have covered it all, and these are the things that we're looking for. And there's just a little look at what greater depth what greater depth looks like. Just moving on to sort of what teaching looks like at St Mary's. This is just an example of the flashback that we do at the start of every lesson. And I think it's one of the most effective things that we've brought in at St Mary's. So the idea of the flashback is we recap what we've learned. So we recap what we did yesterday, we recap what we did last week, and then we recap things from previous year groups. I think it's really important that we do things like this, because often in like the year 6 stats, there'll be a question that on something they learned in year 3. And if the children haven't looked at it again, you know, it could just slip their memory. So I think it's really important we have these flashbacks. And they're a really lovely way to start the lesson. They shouldn't take long, they don't take long. Quick fire questions, the children have a go at it. As a class, we come back together. And for example, we did this one this week, and number 3 was a really challenging one. So we then went through it, we spoke through the steps that we should have taken, and we edited our work. And then I gave them another example of that, and they had another go where they could apply what we'd spoken about. But it has massive importance. And I think, like I said before, that going over it and coming back to topics more than once, lots of times, helps to keep it fresh in their memory so they don't forget it, especially leading up to their SATs. So just another look at our mastery curriculum. So it means, like I've said, that the children are going to get a deep and secure knowledge. So I feel like a lot of people I've spoke to in the past previously said that maths wasn't taught that in depth. So I think now this mastery approach is really, really supporting that. But one thing I think is really important is that fluency, and recognizing that children must have that rapid recall and of their number facts straight away. Often if children have to recall number bonds on their finger, so if they're still going 6, 7, 8, 9, 10. It makes the next step really challenging for them because they've got an overload. They can't think about, they're not sure on that answer, so they can't think about the next one. So for example, if they don't know their number bonds, it often makes addition and subtraction really, really difficult. And you can see it on their face, they're panicking because they can't quite work out the first step of the question. So the children really need to know the basic facts so that their working memory is not overloaded and they can quickly recall the facts. Something I would suggest, if you feel like your child's not as hot on these as you think they should be, then I'd really suggest working on that before anything else. And there's loads of apps, loads of things. Hit the button. Timetables, Rockstars that we'll introduce now. These are all apps to support with that. Just even over breakfast, 6 and what make 10, 6 and 4. Can they do it that quick? And then can they make the link that 6 and 4 makes 10, so 16 and 4 makes 20? It's them having that knowledge of number facts and how they fit together. And often I think once they get that and once that's secure, the children grow in confidence massively because they already know that part of the question and they're not having to, like I say, they're not having that overload of their working memory. So that really does support their confidence as they go through, and it gives them that ability to then problem solve. And it supports them with lots of aspects of that. I pretty much covered all of this. So it's just building that confidence, and like I said earlier, differentiating through depth rather than acceleration. So keeping the children together. We don't have, I know in the past there's been a high group, a middle group, a low group. That's not a thing anymore. Everybody works together. Everyone goes through together on all the knowledge and things that we're learning. However, things are differentiated for the groups that is necessary, and this supports everybody to get a rich and sophisticated education, and that is exactly what we are striving to have at St Mary's. And we do make sure that the children, say a child has maybe not understood something, we'll consolidate it and give that extra support to make sure before they move on. So we have extra interventions, we have extra maths groups and things going on. So just to cover the different ways we learn, I know we spoke about this in year 1, but there's concrete, pictorial and abstract, and they're all really, really important. You can't miss out one and expect them to get the other. I think it's really, really important that children are exposed to all of them. And also it's okay to go back to one. For example, if you're doing number bonds 10 and you're at the abstract, but then you can see there's complete confusion in the child's face, it's fine to go back to getting them to draw it or getting the apparatus out. And that's absolutely fine. And it's not going backwards, it's just building it back up again. So please continue to use anything you've got at home. I know how expensive Numicon is, we've got lots in school, but you can always just use counters, pasta bits, anything that the children can physically manipulate is great and supports them with their learning. So the concrete is the practical, the pictorial is drawing it. So obviously now for 10s and 1s, we get them to draw the 10, draw the 1. We just do a line and dots. We don't want them to draw a big pretty picture that takes ages. And once they've grasped that, we move on to the abstract, which you can see is 3 times 4. It's more of the written equation rather than drawing or anything else. But all of these are equally important, and that is what we use. Just a little picture of lots of the concrete materials that we have within the classroom, anything you guys can have at home. Those little clocks are really super, again supporting their time knowledge, but I'm sure I've shown you that picture before. And again, just a list of all the things that we use in school. And if you ever need any more advice on which ones your child needs to use, then I can always help you with that. But it's really important, that practical aspect. And if children are confused, to go back to it. And it often doesn't take long. Here's just a little example of the ways that we go through addition. I'm going to talk a little bit more in depth about how we teach addition, because it can be quite confusing for the children. But you can see down here, 17 add 5, the children have to use their number bonds. So we want to avoid them counting on their fingers, because obviously as the numbers get harder and the equations get harder, that's going to be more challenging. So trying to, even though they could do that probably on their fingers really quickly, trying to encourage that deeper level of thinking. So there we've done 17 add 3 makes 20, 20 add 2 is 22. So trying to get them to jump to the next 10. So if it was 25, the next 10 is 30. So we want them to add the 5 first and then carry on. And you can see that up here on the number line. We started on a number line and lots of them wanted to add 1, and we said, oh, that takes ages, so what could we do instead? Well, we can add 3, add 2, and again they can use that numbers that we used in year 1, so they know that 3 and 2 makes 5. So it's having all those bits of knowledge and almost piecing it together. So we start up here with that pictorial, and then we move on to the abstract way of learning. And another way of learning is through the column addition, which I'll come on to. Again, after that, we move on to our reasoning and problem solving. And I think really important that the children understand to read the question. I think that's often where they go wrong. They rush the question and then they haven't quite read what it's asking them to do. And it was an example in money today. They had to work out a question where it was like, how much money does Mo and Sam have? And it said they have 2 £10 notes. And they all read, well, they have £10 because they hadn't spotted they have 2 £10 notes. So I think it's really important that children understand that reading is the first job of any of their questions before they get onto it. And as you can see here, the children have to think of a range of answers. So it's how many different totals can you get? And as you can see, they're going 8, 7, 8, 6, 7, 6. So they're finding all the different ways that they can answer that question. Another way that we've done a lot of our learning is breaking it up into a part-whole model. So making the whole and then splitting it into 10s and 1s. So that really helps children to visually see that we've got 3 10s and 7 1s, and we can split them up and we can partition 30. So like lots of little tasks we do in school is just partitioning numbers. What can you break it up to? Do you understand what the 10s are? Do you understand what the 1s are? And that's something you could just chat with your child about as you go through any maths work that you do. Do they understand that that's not a 3, it's a 30? That's a good question to ask them. And again, another way to represent is through a bar model, where there might often be a missing part. Can they figure out what that missing part is to support their learning? And as you can see here, you can use all these pictorial methods. So we've got the part-whole, we've got the bar model, and then it moves on to the abstract way. And often the questions they find really tricky is when there's a missing number. So how do they get that missing number? And I think getting them to draw that part-whole and see it like that often helps. But whereas when they just look at that equation, it's quite overwhelming and they're like, I don't have a clue how to do that. But thinking about getting from how much do I add to the 1 to get to 8, and so on. How do I get from 10 to 20? Thinking about that. So I'm just going to talk you through how we teach our main operations. So addition, subtraction, multiplication, and division into year 2, just to give you guys a deeper understanding, as it can be quite difficult to maybe how you guys learn or sort of how you guys have done it in the past. So like I've said, following the methods that we use, I would start with a practical resource. And you guys can do the same at home, moving into a pictorial, which you can see on the screen, getting them to draw it out. And then as you can see over here, we've got the abstract and we've got the column addition here to help them. So you can see with the column addition at the top, we've got our 10s and our 1s, getting them to understand that. And first we'd show it without crossing 10. So this one does cross a 10, but we'd teach them the technique of adding the numbers together and not crossing 10, and then we would move on and talk about how we do cross 10. And we often talk about carrying a 10, but the word we use in school is exchange. So the children can see that 5 and 7 is going to be greater than 10, so we would need to exchange that into a 10. So we'd have too many 1s, we'd have more than 10 1s, so we then need to exchange it. So that's a way of teaching it. So we have our column addition. And often with our higher retainers, we may remove one of those numbers and give them the answer. So again, turn it into a missing number and give them that sort of opportunity to figure out which part and sort of solve that problem of what's missing and how they can get to that conclusion. And in terms of subtraction, now this is they can often find subtraction quite tricky, but we follow the same 3 methods: concrete, pictorial, and abstract, and it's really important that they can do the column subtraction and addition. However, when they're doing it, it's great if they can get to the answer, but we want the children to understand what they're doing. and understand how to do it. So often, and a lot of them at the minute, we're still drawing it. We're still drawing our numbers out. We're exchanging. The children get confused. They think that they could do 8 take away 2, but we can't. It's 52 take away 28. You can't take away 8 from 2. So getting them to think about, well, we need to exchange that 8 into a 10 and 8. So we need to move it across. But that's something we're still very much working on at the minute, and supporting the children with. As we go through year 2. So we'll give them lots of opportunities. Often we have them on the table when they come in, give them 5 minutes just to have a go, talk through it, and then move on to whatever else we're doing in the day. So lots of little and often is sort of what we need as we go through the year. Just a little overview of how our maths has changed. So we are doing maths every day. Lots of emphasis on mental calculation. So again, like I said, not counting on the fingers, using our number bonds, using that to support them. A lot of interactiveness on the carpet. I often say to children, no hands up, and I just pick on a child to have a go at answering, making sure they're all engaging and all following with me. So we are very good at that, because I often say no hands, so they're quite used to that. And I think keeping maths fun, making it fun even at home, making it a game, making it gaining points. Can they get a sticker chart? Anything to make maths fun. And using things around the house to support them and help them with that understanding. But I think a main aspect is making sure they understand. Ask the children questions to clarify that. I know I spoke about this in the SATs meeting, but there is just another overview of what the children will do in their SATs, the 2 papers, the arithmetic and the reasoning. But I won't go into that too much because we have already spoken about that. Moving on to our mental maths. So we do mental maths every Monday instead of a white rose lesson. And during this, we are really focusing on building up the knowledge of number bonds, to add and subtract, number bonds to 50 and 100, doubles, near doubles and halves, counting in 2s, 3s, 5s and 10s, so your times tables, making sure they know the division facts of those things, and also by adding 9 and 11 by adding 10. So getting 10 is a super easy number to add. So add that first and then either subtract 1 or add 1. So adjusting, that's a really good technique for them to have. I just wanted to quickly mention before we finish about Timetable Rockstars. So the children have all got their own account now. So I will send out the letter for this. I was just wanting to speak on here first to let you guys know. So they have a login and a password. Now this is just an app you can get on iPads that the children can play on. I'm not going to explain it too much. I've put a YouTube link there which tells you all the wonderful things that you can do on the app. It is really great. We got the children logged on Monday, had a great time. And the children earn coins and money and things that they can then spend in the shop. So again, making it fun. But this was just a little example of what it looks like. 5 times 10. Can they answer it? Can they put the right answer in? Now, of course, we want the children to know their times tables in order. 1 times 5 is 5, 2 times 5 is 10, so on. But we also want to go, what's 7 times 5? And they can understand it. So learning it in a random order. And I think that comes from really understanding what it means, that it's 5 groups, not just, I just know the answer, I don't understand it. So through that mastery curriculum that we teach, hopefully the children will have that understanding. But like I say, I'll send the login details out either tomorrow or at the start of next week, so the children can get cracking with playing and learning their times tables. But the main priority is 2s, 3s, 5s and 10s. That's the starting point that we would like the children to know by the end of year 2. However, if your kid cracks that, please don't hold them back. Go on to the next times table and support them with progressing, because in year 4 the children do sit a multiplication check. So it is quick fire multiplication. So the more they know, the earlier on, the easier it'll be for them in year 4. And that's why I wanted to get them started in year 2, because lots of them are ready to have a go at it, and it's a nice fun game for them to play. There's just a few more examples of things they can go on. Still hit the button is really useful. And just making sure with the children you're using that mathematical vocabulary, getting the children to know that equals is the same as, it means balance. So the children are hearing a variety of different vocabulary, just like we do in school. But that's sort of everything that I've got to share with you tonight. If you have any questions, please come and see me. I'm always available to talk. But thank you very much for joining and coming and seeing what maths is like. Thank you, everyone. Bye.
Thank you. Bye.
Thank you. Thank you.
Thank you.
Turn left onto Albert Place.